Now, starting off on page 17 through page 17F, that constitutes 7 pages, we're going to discuss the cycle count program. And let me address some of the data that I have in paragraph 2. Cycle counting was introduced and approved by the certified public accounting profession. And one of the reasons that cycle counting was introduced to industry is the ability to stratify inventory investment through the ABC analysis system and to be able to establish physical inventory frequencies for the A, B, and C items. Rather than take a physical inventory, which has been traditional, maybe once a year, the cycle count is taking little mini physicals during the course of the year, and through the cycle counting program itself and the observations and findings of the cycle count personnel, if there are errors between the physical cycle count and the let's say inventory record bin on hand, if there are differences, and the CPA profession has also established allowable percentages of the actual count to the book count, and we will discuss these there in this particular section, then we can eliminate the physical based upon the byproduct of the cycle count and its associated disciplines. And again, one key discipline is we must have a secure storeroom. So let's get into the outline, which starts off on page 17, item 1. You must process the ABC analysis first. And of course, we went through this process, but step 2, I have a cross-reference in case it is ever required for your purpose a little later. It tells you to go back to page 16, and from there on, pages 16 and those that follow address the ABC system. Once you obtain the ABC items, then step 3 addresses the minimum counts per year. And as A, B, and C under 3 indicate, the A items must be counted a minimum of 4 times a year, the B items twice a year, and the C items once a year. Now, many of my clients that I have worked with over a period of years have items that they will count every week. Some of them they will count every month. And those items are counted more frequently than those A items counted 4 times a year minimum. So anything that exceeds the minimum count is to your benefit, and it is I'll call it an authorized method of installing cycle counting. Now, if you turn to page 17A, prior to the start of the cycle count program, as indicated by step 4, you should take a physical inventory. And what this is preparing us for is the cycle count program itself. If we do a good job in step 4, everything in the storeroom has been identified, it has been counted and reported not only by count but also by bin location, then we're ready to implement the cycle count program. Step 5, there's that naughty word again, security. Without a secure storeroom, I would not attempt cycle counting. You're just going to waste your time and money. Item number 6, all transactions in the storeroom must be recorded from the point you're going to start cycle counting. Now, there are 5 transactions in a storeroom, and that's all, 5. There is a receipt. Now, in a receipt, we have receiving, receive and inspection. There is a receiving inspection activity relative to count. And you say receive an inspection. Yes, accuracy of count just like accuracy of quantity. Then there's a put away, a bin location. That's a transaction. Then we issue material. Then there's a consolidation where we may put 2 or more bin locations into one. I call that housekeeping. And the 5th transaction is cycle counting. Well, since we're instituting a cycle count program, we want to make certain that the first 4 transactions are done properly. So when you're going to institute cycle counting, we should institute the ability to count items, identify the items, and make certain that the storage locations are recorded properly, the issues are all recorded, and the consolidations are likewise recorded. Those 4 functions are identified in step number 6. Then the cycle count program, and it's referred to as the software, will daily provide so many A, B, and C items. Now we have a little illustration that we're going to go through to show you how you could determine what the workload is going to be relative to the cycle count program. The cycle count itself is recorded on a cycle count form, and that form is shown on page 17F, and we'll take a look at it in a moment. The cycle count is next recorded on the storeroom inventory record. That is the bin on hand record by location. Then the next record that is updated is the inventory record. And if there is a difference between the cycle count quantity and the inventory record, and if that difference falls outside of the allowable parameters as identified by step 11, the cycle count is rejected and we have to go back and recount the inventory on hand again. Now if you take a look at the percentage of accuracy that the cycle count program is looking for, you could see that it is very, very tight. And after all, bin on hand is cash. Cash is retained in a bank vault. So our storeroom is the bank vault, and the inventory record is like our passbook or our checking account. You certainly would not want to have your passbook or your checking account with a plus or minus 5% error percentage. What you want is 100%. Well, based upon the ratio of the annual usage value to the number of items in the ABC analysis, here are the percentages of accuracy that the cycle counting program is looking for. On the A items, you must be 99.5% accurate. On the B items, 99.0% accurate. And since many of the C items may be an integral part of a bench stack or 2-bin system, then we go down to 95.0% accurate. Again, if the cycle count is outside of the parameters which were identified in step 11, and I'm now in step number 12, then the cycle count is rejected and should be taken again. Moving on to page 17C, one of the responsibilities of the cycle counters is to determine what caused the error, if errors are found. And this they will develop as they get to more and more cycle count applications. After a month or two, the cycle counters, which are part of the storeroom, these are storeroom personnel, they become like little mini detectives. They can almost smell what caused an error. But if the storeroom is instituting the 4 transactions of count, bin put away, issue, and consolidation, if those are done properly, then the error percentage found by cycle counters should almost be 0. After the count reconciliation, that is the cycle count form to the actual in step 14 is then sent to the financial department, and they would go through the calculation of the error percentage of cycle counting if there were errors. Now, after the first year of cycle counting, we should take a second physical. And here again, we're going to compare the physical count to the bin on hand. And if we have done our homework properly during the course of the year, we have those 4 transaction points that I've just indicated a minute ago under control. We have a secure stockroom. We are finding what caused cycle count errors when an error is determined. Your variance of the physical, the second physical, to the bin on hand should almost be 0. And after that has been accomplished, you could eliminate the physical in the storeroom and continue to do the cycle count program. Now, on 17D, I'm going to show you how the volume of cycle counting is developed. I have on the left-hand column the A, B, C items. In the second column from the left indicates the number of part numbers that are represented by the ABC codes, 500 A's, 1,500 B's, and 3,000 C's, or a total of 5,000 part numbers in this storeroom. We are going to multiply the number of items in the A, B, and C categories by the minimum frequency codes of 4 times a year, twice a year, and once a year. So the right-hand column gives us our maximum number of total counts. Now remember, all parts are not in the stockroom all the time. This is maximum number of counts. So in this case, I have a maximum of 2,000 A counts, 3,000 B counts, 3,000 C counts, or a total annual of 8,000 projected counts. Now, if you turn to 17E, we're going to determine the daily load or workload for the cycle count program. What I'm going to do is to take the 8,000 annual counts and divide that by 250, which represents 50 weeks per year and 5 days per week. That happens to be the working days for this illustration. You should develop your own annual working days, which are actual for your company, but the same application applies. And if I divide 250 into 8,000, that means I'm going to count 32 part numbers per day. The bottom line illustrates the same type of calculation, dividing the 250 days into the maximum A, B, and C items. And as you can see, we're going to count 8 A items a day, 12 B items a day, likewise 12 C items a day. Now, the cycle count form, which is shown on page 17F, indicates the data elements that we want to have minimum-wise on this form. We have a part number, we have a description, and we have a unit of measure. Now, the quantity on hand by locations on item 4 is blank. What we do is we record the location if any items are on hand by bin location. If we have a part number that happens to come out on the cycle count form and there's none on hand, it would not show a bin location. But the part number would still be registered as an integral part of the cycle count frequency for that part number. We'd also have the date the cycle count was to be performed, the employee who did the cycle counting, the inventory record card quantity, inventory variance, if any, following, those allowable percentages that we looked at a moment ago. We have the unit cost. We could therefore develop the financial dollar variance report, if any, and then also determine the reason for the variance, if, again, there is a variance, and the corrective action that has taken place. Now, one of the requirements of the cycle count form is to have that form may be issued 1 but no more than 2 days in advance of the cycle count. This gives the people in the storeroom the capability of determining if there are any maintenance orders that require some of these parts so that those could be issued immediately out of stores. It also gives us the ability to determine if there are any purchase orders or manufacturing orders to receive those parts into stores, and that provides us with what we call an excellent way to have an excellent cutoff procedure. A cutoff procedure is defined by simply taking a cycle count, and let's say I have 10 on hand, and then after the cycle count has been recorded, I can either add to that inventory bin on hand or subtract it, but it will not affect that 10 on hand. Those transactions that occur after the point of cycle counting will add or subtract to the bin on hand after the cycle count quantity has been posted. And that's what we mean by a cutoff. So that 1 to 2 days in advance of receiving the cycle count form is going to help us to intelligently execute the cycle count program even during working hours. Now, page number 18 kind of puts the ABC analysis and the cycle counting program into a conclusion, if you will. Byproducts of the ABC analysis: item number 1 is to identify ABC. Item 2 is the input into cycle counting. Item 3 is the input into inventory reduction, and that's going to be accomplished through our vendor stocking program. Input into a supplier lead time analysis program. Input into a priority program that I've already identified, and likewise the input into obsolescence. But because an item had no usage and it's at the bottom of that ABC listing, does not mean the item is truly obsolete. A true obsolescence can only be determined when we look at the equipment spare parts where used list. If a part number had 0 usage and it was not found in the spare parts where used list, then that item is truly a candidate for obsolescence. And last but not least, some people always ask me, can I lay the storeroom out by putting A items here and B here and C here? And my answer is no, don't do that. Lay the storeroom out, as I've indicated before, by the family or commodity code. And when we get into section number 6, which pertains to the storeroom itself, we're going to show you how that can be accomplished. Now, moving forward into the derivation of EOQ and order point and safety stock, we have some exhibits here starting on page 19 through 37 relative to how some of these applications were actually developed. So again, on page 19, we have the EOQ formula. I mentioned earlier that on page 20, we're going to look at those items that constitute the carrying cost. The carrying cost is comprised by adding on an annual basis the insurance that we pay for our assets, the taxes that we pay, the cost of capital, what the cost of storage is, and that is the percentage of, let's say, the maintenance of a building that the storeroom is retained in. Also, any cost like power consumption, and if any air conditioning is involved, HVAC costs, and also any maintenance costs that would apply directly to storage, and the taxes and the insurance on the facility would be prorated back to the storeroom. And last but not least would be the obsolescence cost if you truly have an obsolescence program. Now, I will explain the reason for that little fulcrum on top of this little balancing scale in one moment. But I first want to address the purchase order cost, which is on page number 21. And again, these are annual, and they comprise the annual purchasing department expenses, which includes payroll, the receiving department expenses, again, payroll and all other costs, receiving inspection, and any portion of data processing cost that may be used for the above three. If I add those all together and divide by the number of annual purchase orders I'm going to issue for the following year, and I divide that into that total annual cost, I'm going to get what is called the average purchase order cost. Now, the two things that are required in the economic order quantity is the cost to carry, which came from page 20, and the cost to acquire, and there we have two acquisition costs. One is the manufacturing setup cost. That comes directly off of the manufacturing routing. We take the time of setup and multiply that by the setup labor, and we get the setup cost. But when it comes to a purchased item, all of the purchase order costs are the same for all purchased order items. So here we have the cost to acquire via purchasing. Now, if you were to overlay page 20 to page 21 on top of each other, we would have a balancing scale. And if those two scales, in other words, they don't tip one way or the other, but they balance perfectly, then that is the most economic method of procurement, when the cost to acquire is equal to the cost to carry. So in order to utilize this in terms of a formula, let's go through a little illustration which is on page 22 that demonstrates how the EOQ equation was developed. And very simply, we have some data elements like the annual usage of $1,200. S is the purchase order cost of $1, don't we wish? And the carrying cost of 10%, another, don't we wish? But to make it easy for us, we'll use those data elements. Now in the body of the form, you notice from the reading from left to right, we have a frequency of ordering. So we have 5 different frequencies. And the next we have order quantity. Then we have average inventory. Then we have the carrying cost. And then the number of orders associated with those frequencies on the left-hand column. Then the purchasing cost. And last but not least, on the right-hand column, we have the total cost. So let's take a look at the development of the number of orders and divide that into $1,200. So if I take 2 into $1,200, that's going to give me $600 of ordering cost for semi-annually. Then if I took 4 times a year and divided that into $1,200, that's going to give me the quarterly ordering costs, and that's how the second column from the left is developed. Average inventory is 1/2 the order quantity, and that is how average inventory is defined and how the carrying cost is defined. So I'm going to take the order quantity column and divide it by 2, and I'm going to get the average inventory column. And you'll notice it's actually 1/2 that order quantity column. If I multiply the average inventory by 10%, and remember in computations we take the percentage and we convert it into its decimal equivalent. So if I multiplied $300 of average inventory times 0.10, I get $30 of carrying cost. And therefore I continue the balance of the 4 other methods of ordering. If I take the number of orders, which is the third column from the right, and multiply that by $1 per order, I will get the purchasing cost, which starts off at $200 for semi-annually, all the way down to $24 for semi-monthly. Now the right-hand total cost is derived by adding the carrying cost to the purchasing cost. So $30 of carrying cost for the first item plus $2 of purchasing cost is $32, and that's how that right-hand column is derived. Now, if you peruse down that right-hand column, you're going to notice something unusual happening. When I get down to the third method of ordering, bi-monthly, that is a total cost of $16. But when I move to monthly, the cost goes up to $17, and then as I go to semi-monthly, it goes up even higher. Now, what has happened is this. The total cost starts up high, it goes low, and then it swings back up again. Now, that is the curve for an EOQ. The usage curve, or the ordering curve, okay, is a straight line, and the carrying cost curve is a geometric curve. And if you would turn the page, we have those three curves all defined for you in what we call the EOQ analysis. The calculation was developed scientifically with mathematical terms. And what it is accomplishing is the development of the carrying cost associated with the development of the acquisition or the setup cost. Simply put, where these two costs are equal to one another, that's the most economical order quantity. Now remember what I said earlier when we went through an example of an EOQ calculation. You should take the annual usage and divide it by the EOQ. If that order quantity gives you less than, let's say, 4 turns a year, and this is, my minimum turnover analysis. If it's less than 4 turns a year, adjust the order quantity downward so that you can get higher turnover requirements. That analysis should not increase the purchase order cost, and it should not increase the, let's say, the carrying cost. And you could determine the end result by going through some of those mathematical computations utilizing the EOQ formula. Now, I'd like to walk through the derivation of the order point, which is on page 24, with an illustration of the order point system on page 25. But first, let us go into the order point formula. And as it indicates, the order point is equal to some type of usage times the lead time. Well, we previously have indicated that we have to calculate average usage over the lead time period. So what I am going to kind of force you to do is to write the word average in front of usage for that first half of the order point formula. I could put average in there for you, but some people will take usage and multiply it by the lead time as an integral part of the order point calculation. That's wrong. We have to develop the average usage first and then multiply it by the lead time. And then again adding our safety factor for a predetermined service level and multiplying that by MAD, mean absolute deviation. Now if you look on page 25, we have a kind of what I call a busy exhibit, but it's very easy to follow if you would just follow some of the things that I'm going to be talking about. Up on the top where we have OP, that's order point. And right below that, we have a dispersion of many individual lines moving from left to right below OP. Those individual lines are called usage lines. If you were to take a horizontal line from order point over to that left vertical line and put a nice big dot around it, that is the level of inventory on hand that you should order when you reach that level. So therefore, that left vertical line is called bin on hand. Now I encourage you to start putting down some of the data that we're going through so you're in a position to intelligently review and explain this order point exhibit to other people, especially if you're going to institute an internal training program. Moving down that bin on hand, we're going to hit safety stock. So the safety stock is that boxed portion which is at the lower part of the exhibit. And safety stock, as you know, per our previous calculations, is calculated. Safety stock is equal to mean absolute deviation times the safety factor. So what we're going to add to that is we're going to add average usage times the lead time. Well, we show the lead time here, and that is a horizontal line. The average usage is developed by finding out what each one of the usages are for those lines emanating from order point and moving over to the right. We summarize that and we divide by the number of time periods that we're analyzing, and then we add that to safety stock and we get our order point. That vertical line, which is at the right-hand side, has two terms to it, and that is it's bin on hand plus order quantity received. And you could see that if I am the third usage line from the bottom, I have gone into safety stock. I've used a little bit of safety stock, and then that line, that vertical line proceeds upward. Well, that is where my inventory level was, bin on hand, and when I had the lot size received, it brings me to a nice, comfortable inventory level on hand. And that's how we read and interpret the information that is developed on this particular exhibit, and that really is how the order point was developed. Now, if we turn to the next page, we're going to look at a graph which is entitled Service Percentage, which is the horizontal line, and inventory investment and thousands of dollars on the vertical line, and that happens to be safety stock investment. That curve that you see is called a service level, which is another term for service percentage, safety stock curve. And looking at the horizontal line from left to right, as we add additional service levels, going from one service level to another, you're going to see we're adding more and more safety stock. So safety stock goes up exponentially as we increase the service level. And there's one additional note. You'll notice on the upper portion of where 100% service and the service curve are, those two lines never touch. That service percentage can go up to infinity, but it does not hit 100%, which means that statistically speaking, we will never have continuously 100% service, but we can have less than 100%, like 99.99%. And those percentages are shown on page 27, which is the next page. And this is a standard table of safety factors for what we call normal distribution for mean absolute deviation analysis. So the right-hand column is not entitled MAD. The data under that heading MAD is the safety factors for the predetermined service levels that are on the left-hand column. And I know it may seem a little confusing at first, but years ago we used to have another table called standard deviation analysis. And there was a great deal of mathematics and computation involved. And when we started to computerize the inventory management programs, it became quite apparent that there should be a shortcut, a better method of trying to compute safety stock. So as a byproduct of computerization, these safety factors were developed for mean absolute deviation analysis. Now, the way you read this particular table, if you remember earlier in one of our order point examples, we said for a 95% service level, our safety factor is 2.06 using the MAD approach. So if you look and find 95% service level on the left column, read across, the safety factor is 2.06, and accordingly, for every percentage level, except where you go below, let's say 75%, that means 3/4 of the time you're going to have a stock out, which I don't recommend you work with. But if you go below that, I don't think you're really going to work in an order point environment that is going to be conducive to having parts on hand, and especially parts on hand for future unplanned requirements. So the matrix that I talked about before, where we had the where-use code tied in with the service level and tied in with the safety factor, well, we started out with our clients at a 95% service level. So if you turn to page 28, here is that matrix that I've talked about before and just a moment ago, and there are 3 columns. The where-use code is the numeric code indicating how many places a spare part is used in. The service level percent is something that management would define. That's the fill rate out of the storeroom for future unplanned requirements. And the safety factor, that is the MAD safety factor, comes from the previous table. Now, you'll notice that we start off with a where-use code in a range of 1 to 3. Then we move 4 to 6 and 7 to 9 and 10 to 12 and then greater than 12. This is a byproduct of working with companies like yourself that have instituted the planning in the unplanned function. But you also notice that there is a note which addresses the average machine hours of utilization that has been recommended by the OEM of that asset. And I would like to address let's say a fixed frequency code illustration for you and some of the major problems that can occur if operations and maintenance management do not talk to one another. Let's assume that we are working on a 1-shift basis. We have a frequency code of 3 months or every 90 days, and the OEM of the equipment says you must replace this part number every 90 days, working 1 shift, 40 hours a week. And therefore, every 90 days, every 3 months, we're going to follow that PM requirement. What happens when operations goes from 1 to 2 shifts? Are you informed? Invariably, the answer is no. And what happens is now we're going from 1 to 2 shifts. That means the frequency code should have gone from 90 days down to 45 days. And you know, on the other hand, we could go to 3 shifts a little later. And that means the frequency code should have gone from, let's say, 45 days to about 33 days. The key requirement of a fixed frequency using a shop calendar is that when operations changes, what is norm to the OEM, the designer and the manufacturer of the equipment, is not going to be norm to the user, and that is operations. So under a shop calendar fixed frequency environment, operations and maintenance management must talk to each other, and when there are going to be operational changes, the frequencies likewise should be changed. Now, maybe you may be a candidate, if you're under such a fixed calendar environment, to put machine hour meters on your machines, which will give you the actual hours of operation, and therefore you can adjust the PM frequencies based upon meter readings as opposed to a fixed shop calendar. I believe this is good advice, and I implore you with operations to set up the communication channel which you need. We've talked about the min-max system and the two different formulas, and on page 29 I merely want to address some of the criteria. Lead time must be immediate. When we set up vendor stocking programs with suppliers, we're basically working with supply houses or with an OEM of equipment that does have a stocking program set up for their recommended spare parts. Usage must be constant. Now, I'm not talking about daily requirements. Maybe I use an item once a month, but if there's repetitive use once a month or once every 3 months, I have some consistency in that usage pattern. The minimum is going to really depend upon two things: the usage of the item, the frequency of usage, and the lead time from the supplier. If a supplier was local and the supplier always had inventory on hand, I could use the min-max system where the min is 0. If the supplier had to ship me parts in some lead time interval, there is some distance to travel, I may want to have the minimum be 1 or 2 paces. Now remember, I said I may want to. There's no formulas, there's no criteria that I know of in terms of establishing the max and the min. These are set using the guidelines of the inventory policy of the supplier and the lead time relative to that supplier. The order quantity, remember, in step 5 is always the difference between max minus the min, but where the min is equal to 1 or more, we have to add that deviation below the minimum. And what I've done on the next exhibit is to actually show you graphically where the min is greater than 1, how that system works. And in this case, we have 2 deviations over 2 time periods below the minimum, and therefore we would use the order quantity formula as indicated on the top portion of this exhibit. Now, the next application on page 31 is going to address the inventory that is going to be stored in the various repair shops if you have more than one under what we call a bench stock. I referred to it earlier as a 2-bin system. Now we're adding another dimension called free stock. So I don't care what you call it as long as you are consistent in your definition of this application. The procedures for the 2-bin or bench stock program are outlined on page 31 and 32. The first thing we want to do is establish the part numbers in the program. Then we want to establish the stocking inventory levels that we want to actually carry in the supply houses. Then we want to determine where the items are going to be located and then how physically they're going to be stored. In this case, we could use the carousels, you know, the little pie-shaped storage containers. We could also use bins with tote pans or any other type of a device that is going to be retained in the same area, and that's the key, in the same area. Because once we've developed steps 2, 3, and 4, the requisitioning and the replenishment system is going to be supported by the storeroom. And what they are going to do is periodically review the physical area where the material is going to be stored. They'll have some type of a checklist with them, and we're going to show you one checklist in a moment. And what we want to do is we're going to track the usages, which is the top of page 32, item 6. We're going to develop the replenishment quantity, which will actually be prepackaged, where prepackaging can be done by the supplier. We're going to track the vendor lead times to make certain that what we're carrying in the storeroom is not going to be depleted by the next issue, because we want to go through a replenishment of the storeroom bin on hand. And that is another key issue where a min-max system could support this type of a program very easily. And then as we see the usage go up or down in the repair shops, we can revise those quantities as determined. Now on page 33, we have what we call a disbursement record, and that is out of the storeroom. And in this exhibit, it's for the mechanical department. It is for roto bin number 5, tier number 5, and always tier 1 is the lowest tier to the floor. In this case, outside the periphery of the roto bin are the various part numbers, their descriptions, and the quantities that are going to be replenished in each one of those little pie-shaped areas. Now, there are 3 approaches that this system can work under. Manually, I would have documents like we have here on page 33. They could be affixed to a clipboard. The individual from the storeroom literally goes out to the different repair shops, physically eyeballs the content that are in those individual storage areas, and if he or she feels that replenishment is necessary, and we don't have to be 100% perfect here. The key is try not and run out of those items. That could delay a repair maintenance order, and we merely put a check mark in the right-hand column called replace. We would go back to the storeroom, get all of those items, put them on a little upright 4-wheel dolly, bring them back out to the various repair shops, and then put those into the appropriate container and recycle the container if recycling can be accomplished, and I recommend you consider that. Then what we would do is to take these documents, and each and every inventory record would have to be updated. If I am in a CMMS environment, I could have these items, these pages, like on page 33, those documents recorded for me, get them printed out from the 2-bin system, go through the same mechanics of replenishment, but here, rather than manually post the requirements, I would have to put through my data entry terminal the individual part numbers that have been issued out of the storeroom, and I would have to put the quantity issued, and when I'm through, I'd hit an entry button, and all of the records could be updated simultaneously, or you may have the software where each record would have to be updated on a single record-by-record basis. Now, the third element is going to eliminate the need for page number 33, and it's going to eliminate the data entry terminal, and that is to use barcoding. In addition to the data that's on the, let's say, the container where the material is to be housed, I have one additional element called the barcode label. I don't need this page 33 document anymore. All I need is a handheld reader, a barcode reader. I would merely go out to the different repair shops. I would wand the labels that require replenishment. I would come back into the storeroom. I would upload that handheld wand into, as an example, a upload terminal. I could use an RF loop. It all depends on how it's established. And simultaneously, I'm going to record all of the entries relative to issuing the material to those repair shops, but physically I'm still going to have to remove the items from the bin location and go through the steps of replenishing those bin location inventories. This is a key element that maintains the inventory integrity in a repair shop, but it does something else. It eliminates maintenance personnel to come to the crib, fill out a requisition for these low-cost items. That is the payback of the development of the two-bin, the bench stack, or the free system. Now, continuing on page number 34, we show you what is referred to as a decentralized storeroom location. And in this case, this would be under lock and key, but it would only contain items that are used by those four manufacturing departments. They could be non-manufacturing in a service industry. And any maintenance requirement that needs those items would be pulled from that decentralized storeroom by the craft person itself. Once I remove the item from stores, we have provided within that decentralized storage area a list of the items that are retained in the storeroom by part number and description. The third column would be the unit of measure, but the fourth column, most importantly, would be the quantity that that craft person would actually pick from that particular location. In these cases, if those parts are on a maintenance work order, they could automatically be deducted in advance, and all we would have to do is make certain that that craft individual had a pick ticket along with the maintenance work order to reflect the part number, description, unit of measure, and quantity required. This saves a lot of time for items that are repetitively used either in a planned or an unplanned environment. It saves craft time from going back and forth to a central storeroom. Now, on page 36, we're addressing, or 35, excuse me, we're addressing the minimum order quantity or number of days supply, which in many cases gets us kind of tripped up in the language relative to a minimum inventory or a vendor unit pack. Now, I only have to share with you the two data elements that are given. We're looking out over a 20-day planning period, so this undoubtedly is for planned requirements, and the record indicates 20,000 minimum order quantity. What record? The inventory record. Now, under the first scenario, we look out 20 days, and we show that there is a requirement of 1,795 pieces. So we would order 2,000, since that's the minimum. We'd get those parts in, and we would apply them against that 1,795 pieces, which are planned over the next 20 days. A little later, we have a second planning scenario, and for the next 20 days, we need a requirement of 2,365. Since the minimum is 2,000, we're going to order the actual requirements. We're going to order 2,365. And guess what happens? We get a phone call from the supplier, and the supplier says, you've got to order 4,000. Now, what caused that 2,000 minimum to go to 4,000 when we only needed 2,365? Here is what I would ask you to write down under the second scenario, please. And it goes as follows. Is 2,000 the vendor minimum or the vendor unit packaged quantity? I'll repeat that. Is 2,000 the vendor minimum or the vendor unit package quantity? Undoubtedly, purchasing forgot to ask the question, is this 2,000 the minimum or is it your unit pack? In this case, I think we made the assumption it was the minimum in error when it should have been the unit pack. So please, always ask the question to the supplier to make sure you understand what that minimum quantity is. Is it the minimum or the unit pack? Continuing now on page number 36, there is a complete derivation of a supplier minimum. It is established by the supplier. And if you turn to page 37, there is a complete derivation of a supplier unit pack. Both of those, the minimum and the unit pack, as we've said before in this program, are a supplier responsibility. And if we don't like the minimums or the unit packs, then maybe you may negotiate with the supplier so you could change that minimum or change the unit pack, which would represent more closely to your specific requirements. Don't forget, those are established by the supplier. Now, starting off on page 38 and finishing on page 41, there are 4 pages here that we want to address the vendor stocking program. This is probably the greatest return today on inventory investment reduction and also the reduction of inventory carrying costs. So let's take a moment to go through these particular steps. As step 1 indicates in the vendor stocking program, we first must establish the part numbers that will be used. Secondly, we also have to develop the annual usages for those part numbers. Now, as a byproduct of the ABC analysis, we already have calculated the annual usages. But in this case, we're going to project ourselves 1 year in advance. In other words, a vendor stocking program should cover 1 full year in advance. And we have to ask ourselves the question, was the annual usage that we calculated previously in our ABC analysis, that was for the past year. Now, will the usage be the same? And if the answer is yes, we can use that annual usage. If it's going to be higher, we should adjust it. Likewise, if it's going to be lower, we should adjust it. The thing we don't want to do is to put a part number and a quantity in a vendor stocking program and find out that it's going to be obsolete in a very short period of time. So those are the types of analyses that should take place. Then what we're going to do is we're going to calculate the actual cost for all of the items. That would be the cost of the item multiplied by the annual projected usage. Then, as step 4 indicates, if you have some critical items and the volume is such whereby you may want to select more than one supplier. So in this case, you could share the business 50-50 or 60-40. I would not recommend you go below 40%. The 5th step is to negotiate with the supplier the benefits, including any annual discounts or a fixed cost to you over a minimum of 6 months. And continuing on to the next exhibit on page 39, we're going to establish the reorder criteria for all items. In other words, when do you reorder? Now, the min-max system, as I indicated before, would be a good candidate for these types of items. And 7th, we would establish the delivery lead times. And again, you'll notice that the order quantity is really a byproduct of the lead time, and that is identical to the analysis that we discussed when we talked about the min-max system. We're also going to establish with the supplier the inventory levels that the supplier must have available for you at all times. And I would kind of underscore that word must. Those are his or her minimums to support your continual usage of those items in the vendor stocking program through the planned, the planned future, planned and scheduled maintenance work orders. And item number 9, you can obtain the necessary data processing hardware, and in most cases, if you are utilizing CMMS, you could use the same terminal that is in the storeroom. You may have to acquire a modem, which is the interface between the terminal and the telephone line, and probably have a dedicated telephone for vendor stocking. And the program, which is really supported by the storeroom, and here is another indication of the integration of the inventory system with the storeroom system. When storeroom personnel see those minimums get to the level of reordering, what they will do is pick up the telephone, dial the number of the supplier, and in most cases they will dial directly into the supplier's mainframe. On your screen in your storeroom, you will see your part number, description, unit of measure, the quantity that the supplier has on hand by his or her bin location or locations, maybe the supplier part number, and also the minimum quantity the supplier has indicated he or she would carry for you. And then there would be a column which would be the quantity to be released, and that's really where the little asterisk would lie, or the cursor, and then the storeroom personnel could scan up or down based upon the number of items that are on your vendor stocking program and actually indicate the quantity released. And once that is all done, hit the entry button, and out at the vendor's location would be printed maybe a 5-part purchase order form, which is your PO, and it would indicate your part number, description, the unit of measure, the quantity you released, and maybe below that the vendor's part number, and that would likewise be used as a copy of the packing slip, the pick ticket by the supplier. A copy would go to your purchasing department, and a copy could be retained by the supplier's order entry department. Now, what you have done is you have actually updated the inventory record for the supplier. You have bypassed all of his or her order entry processes. You've done the actual extension to generate a invoice for you. You have updated the supplier's accounts receivable record, and you've done a lot of work for that supplier. The benefits to the supplier are the reduction of all of the indirect labor costs associated with order processing. They would still have to pick, pack, and ship. Now, as item number 10 indicates, we want to establish security codes, and those can be established by the supplier and yourself to make certain that no one inadvertently can get in and order parts from your crib, if you will, to the supplier. And once the system is tested on step number 11, you can implement the system and then make changes accordingly. That is the steps on page number 40, 13, and 14. Now, those are the procedures for the vendor stocking program. Some of the benefits, as I've derived earlier, are on page 41. The first one is to eliminate interviewing sales personnel, which means that the supplier has a potential cost reduction right up front through his sales organization. We eliminate generating purchase orders. We do that through a terminal, and we eliminate supplier quotations, but we probably would generate a quotation where new items enter the maintenance organization. We're going to reduce overall purchase order processing time. You should be able to eliminate expediting suppliers, because when you look at the terminal, you know exactly what the supplier has been on hand, and you also know what that supplier's minimum is based upon the program when it was originally established. You're going to reduce inventory carrying costs for yourself, which is the major benefit. And last but not least, you're going to reduce your internal storage costs. One of the major benefits of a well-planned, organized, and scheduled maintenance management program is to reduce inventory investment and subsequently eliminate or reduce the carrying costs associated with that inventory reduction. Now, starting off on page 42, we have 4 pages relative to the development of a JIT program. And if you remember earlier, I did indicate that we would discuss JIT at the end of this section. And what I have done here is outlined for you the various data elements, the procedures, and the systems that must be in place to consider JIT. So let me very briefly walk through these steps, because you know we've discussed each and every one of them previously. First of all, we need a complete list of all assets that are going to be maintained by maintenance. We also have to have a spare parts where used list. We likewise need the lead times of all items that are going to be an integral part of JIT. We need the total lead time of not only those that are going to be for JIT, but other applications, which can lead to, again, the reduction of those non-planned maintenance work orders. In step 4, we want to make certain that we have trained the suppliers that they have a thorough knowledge and understanding of the JIT program. If those suppliers are certified, then we can, as I said earlier in this section, have suppliers deliver material right to the job site at where that ever can be accomplished. The suppliers, through certification, have proven that they have no quality problems with their parts, and item 6 indicates that they are shipping their quantities 100% accurate. Continuing on page 43, the delivery dates are being met 100% on time, and remember, if they can't meet these criteria, they are not going to be certified, and therefore they may not be able to support your JIT program. The maintenance work order planning and scheduling system is planning and scheduling both planned and unplanned maintenance work orders. Now, how can I schedule unplanned maintenance work orders? If you took the maintenance work order requests, which are unplanned, and converted those over into, let's say, scheduled work orders, and you could prioritize those scheduled unplanned work orders, you'll be able to schedule close to 99% of all maintenance work order requirements. The 1% would be allowed for very high priority work order requests, and those work orders that would be generated as a byproduct of emergency orders. The maintenance inventory control system is recording both planned and unplanned requirements, which is in item number 9. All of the special tools and equipment are known and available for the work orders. And step 11 indicates that all of the craft requirements are likewise known. Continuing on page 44, item 12, the maintenance storeroom, which is this program, has a defined area to house unplanned maintenance work orders. The next step is the maintenance work order scheduling system is interfaced with the manufacturing work order scheduling system and the maintenance purchase order system, which says you are now getting close to my definition of world-class maintenance. The equipment asset will be available as scheduled by the maintenance work order. Well, that step 14 cannot be accomplished if step 13 is not addressed properly. Step 15 is the maintenance work order reporting system is accurate and timely. That means we're getting observations and findings and recommendations for operating improvement, not only from our maintenance group, but also from machine operators or other operators of our assets. And then step 16 indicates that changes can be made to the JIT schedule from plan to completion with ease. And on page 45, the last two steps in a JIT program is the maintenance JIT program has top management support. That also means that top management thoroughly understands the JIT program, and maintenance management and manufacturing management have both contributed to the design, the training, and the implementation of the maintenance JIT program. Now, these 18 steps are no different than those that would be followed if we were going to implement PM, major minor overhauls, and other planned requirements. Now, this concludes the data in Section 4, the Inventory Management Program. So what I would like to do now is move into Section 5, which is Purchasing Management, and talk about some of the basic data requirements relative to the purchasing management system. Now in Section 5, as I indicated a moment ago, we're going to talk about purchasing management. And if you would turn to page 1, we're going to look at the data elements that the purchasing management system should consider to be in place so that purchasing can properly support the maintenance work order planning and scheduling system, support the inventory management program, and likewise the storeroom. Some of the basic data elements would be A, B, and C, the part number, the description, and unit of measure. And you'll notice I always address those three data elements in every section where we talk about the part number. This is a good discipline to have in your maintenance program because many times the unit of measure could indicate to us that a part number and its description is the incorrect part number and description that we may be talking about relative to spare parts planning. We have the purchase cost. Now those are the cost to procure items. That would be item C in our, let's say, EOQ formula. We have lead times. And you notice, like purchase cost, lead times is plural, especially if you have more than one supplier and they do not have the same lead time. Now, item F indicates all of the supplier information, and that could be a myriad of different data. A supplier name, address, telephone number, fax number, the main contact, the financial status of the supplier, and anything else relative to supplier information that would make a very key database for the supplier data. We also would have any open purchase orders that are outstanding, open requisitions, those suppliers that are currently under a supplier stocking program. Where we have 2 or more facilities, as I mentioned earlier, we would indicate what suppliers and what part numbers are under what we call our corporate procurement program. Where we set up a supplier performance or appraisal program, we want to know what suppliers are currently in that program. Now, other information can be developed, and one key data element to add to this list would be any suppliers that are currently certified and any other type of data to support the integration of the vendor base to the purchasing activity. Now, in page number 2, there's a very comprehensive list. I'm not indicating it's complete because, again, all lists are never complete for the audience that would be in our various seminars, but there are some activities like supplier selection. What's the criteria that you would use to select a supplier? I think 4 major criteria would be ability to deliver on time, the quality is accurate, the count is accurate, and maybe the cost is within the cost range that we are expecting. We have supplier analysis. Now, that doesn't analyze the 4 items that I talked about under supplier selection, but analyze the supplier in relative to financial strength, net worth, the number of different customers that he or she has, and also whether the supplier is affiliated with any local activities, youth organizations, the local chamber of commerce, and so forth, which indicates his or her interest in the activity or the surrounding area that they are located in. We would issue purchase orders, a very key element, but the follow-up on the purchase orders is extremely important, as indicated by the next function. Obtain quotations, get price negotiation where price negotiation is a requirement, do market analysis. Now, we're not expecting people in purchasing to be component or spare parts design engineers, but market analysis would follow such trends as a few years ago the luminary industry changed the way that they are designing and manufacturing lumens to provide us with longer lasting lumens with less power consumption and at a least cost. The motor industry likewise did the same things. We are getting the same horsepower, if not more, with less operating expense. So those are just, 2 of some of the standard market analyses that take place. You really have to keep, your nose to the grindstone in terms of product development by suppliers, and sometimes the way you could obtain that information is by direct communication to the supplier itself. Purchase price analysis is the function of analyzing the supplier's quoted price with other suppliers. Tracing supplier shipments is a real key requirement, especially where you are dealing with suppliers that are offshore, let's say in the international community. The sale of scrap and surplus is the final disposition of your scrap or surplus, and there are 2 methods of disposition that I would recommend. One is have a bonded scrap dealer take the material and give you certification that that material would go to a bonded landfill program. Secondly, same application, get a bonded scrap dealer, and he or she would indicate that that material is going to go to a smelt shop. And either way, any proprietary spare parts that are scrap or surplus will never find their way back into the marketplace. alternate supplier selection indicates you have a primary supplier and you have an alternate, and here you may want to continue to provide the alternate supplier with some purchases so that you can continually review the integrity of the supplier's quality, his or her delivery performance, and likewise the accuracy of the counts against their shipments. We also would approve invoices, and the next two are something that we include in purchasing functions, but they should not be developed by purchasing itself. These should be developed by House Counsel, which establishes penalty clauses, and those generally would be established when you're purchasing new material or you're dealing with a very large project through contractors. And legal aspects of contracts follow the same general principle, and again, that should be developed by House Counsel. Issued delivery and shipping instructions is another key function of purchasing. And the last two, issuing billing terms, that is a byproduct of financial input. So we would get that type of direction from our financial department. And the last one, reports to management. The easiest way to develop that information is to ask the management personnel, both in maintenance and outside of maintenance, what type of purchasing reports do you want from the purchasing function, and then as long as the data is in the purchasing system, we can always extract that information in terms of a report. Now, the next two pages, pages 3 and 4, are part of the training of a purchasing person when we're selecting a supplier for spare parts. We're not advocating that the purchasing person or persons have to be, let's say, spare parts design engineers. They don't have to be facility engineers. But the way you get this information is through learning. And you learn through reading and asking questions. And pretty soon, you're going to become a professional buyer or a purchasing person in the maintenance management program. Here are some of the questions that you probably may want to start off with in developing the experience relative to spare parts. How unique is the spare part? Now, if we're talking hardware, we're not going to discuss the uniqueness of hardware. So when you really think about it, we probably may be talking about a few items, no more than 30 or 40, that would require this type of an analysis by purchasing. What are the unique operational requirements of the spare part? In other words, what actually makes that spare part motivate? Is it power? Is there AC involved, DC involved? Is there hydraulic and pneumatic applications and other types that would actually indicate that those are required for operational requirements of the spare part? How many suppliers are there? And how many have you used, and what is their method of delivery, and how well have they been rated relative to quality, count, and delivery? And here you can go through a ranking process. Which suppliers has the best quality? We're not dealing on price alone in today's maintenance purchasing environment. We want to have quality. We want to have, let's say, the accuracy of receipt date and the accuracy of the quantity received. And there are some other applications, and we're going to review those in a few minutes when we get into setting up a vendor performance and rating program, which then would be the stepping stone into vendor certification. What supplier has the longest longevity? You and I both know that we could purchase and interchange a half a dozen bearings from 6 different bearing manufacturers. But 2 manufacturers will give us 25 to 30% of more operational life than the other 4. And this is another key consideration when we talk about the performance of a supplier, longevity or lifespan of the spare part. Which supplier has the best delivery record? I've identified that earlier. And are there alternate products? Now, alternate products are substitutes. And before we can actually set up an alternate product record, we must have approval from maintenance management. And if there's a facilities engineering department in your organization, then they likewise should indicate what alternate products may be used. Now, continuing on page 4, item 8, what is the operating history of alternate products? And that's only on the assumption that you did bring an alternate product in and we're actually keeping track of the operational lifespan of that particular item. Step number 9 is the technical support that you receive from a supplier. In many cases, suppliers have 2 types of sales personnel. They have what is called an order taker, and all that person does is take orders and communicates the requirements back to his or her shop, and then they will fill the order in its entirety or partial or whatever. But the second type is the type that I like, and that is we have not only a person that represents a supplier from a sales standpoint, but also from sales engineering, product engineering, and understands how the supplier organization can support you as the customer when different applications arise. So there are key requirements when we're talking about what technical support the supplier can provide. Item 10 are the supplier's inventory policies. And that would be another key indication as to those parts that I may want to move immediately into a vendor stocking program. That is based upon the inventory policies of suppliers. And then next is what are the supplier's warranty and service policies, and we went through some of that data before. Those were data elements that were on our new part notice system, if you remember, in section 2, but that should be recorded not only in the purchasing system, but that likewise should be recorded in the asset spare parts record, which is function 1 of the maintenance management program. And again, as item 12 is alluding to, what other information do you want? Now there's kind of a little notation here for the purchasing person to become familiar with critical items. And that is, like I said before, don't be afraid to talk to suppliers, supplier representatives. Don't be afraid to talk to facilities engineers. And most importantly, talk to the craft personnel in your organization. There is an amount of resource in that organization, and the only way that you could tap it is to communicate what your requirements are. Now, moving on to page 5 and concluding on page 6, we have a list of information here for your perusal and selection relative to what I call spare parts purchasing considerations. And again, this is not for the traditional run-of-the-mill electrical and plumbing and hardware and other items that we can buy from any supplier at any point in time. I'm talking about some of the key issues relative to spare parts. Again, the first 3 are the part number, the description, and the unit of measure. Now here we have the input into the unit of conversion. And we've talked about the requirements of conversion. We also should understand the where used code. How many different places is that item used? Like the inventory system, it's going to indicate to the people in purchasing the criticality of that spare part. Remember, the higher the where used code, the higher the probability that there could be an unplanned requirement. If you had 0 on hand, how fast can you get the item in if there is an unplanned requirement? You should also have the freedom to look into the inventory classification code. You must track the lead times as quoted by suppliers. The quantity required should be reviewed, and there may be questions that you may want to ask inventory management if the quantity seems abnormal based upon previous quantities that were purchased for that item. All you're doing is trying to develop a check and balance between inventory management and purchasing management. You have to know the date required, and hopefully the date required is outside of the lead time quoted by the supplier. If it's internal within the lead time, then that says you may have to do some hardcore negotiation and discussion with the supplier to get it in sooner than what he or she had quoted relative to their, what I would call, normal lead times. If it's a planned requirement, you want to have the maintenance work order number actually printed on the purchase order, and on the maintenance work order number by part number, you'd want to have the purchase order printed on the maintenance work order. This, therefore, cross-references purchase orders to maintenance orders and maintenance orders to purchase orders. And this is a key requirement for the people in the storeroom so that when merchandise is received, they know immediately what purchase order is for what planned work order, and that material can be placed in the planned work order staging area, and what purchase order is for, let's say, normal stock storage, which would be required for future unplanned requirements. Special quality requirements should be recorded on purchase orders, and those may be used when material is received and they are processed through receiving inspection. Similarly, item number 12 is discussing the special packaging requirements. This is becoming more and more important, especially when we're purchasing offshore. Shelf life codes are a key requirement we've talked about many, many times before. The shelf life code is recorded in the storeroom record. It is recorded in the inventory record. It is recorded in the item master spare parts record in function 1 of the maintenance management program, and it is totally coordinated by the purchasing system. All shelf life coded items are identified as a shelf life item on the purchase order, so that when items are received by the storeroom, they can compare the shelf life code, which may be physically put on the part or on the package or the container with the average usage of that item to determine whether parts may be on hand after the shelf life coded date has expired. Naturally, purchasing has to support price and quantity discounts, and the supplier information, the name and address, and all of the data that we've talked about before. Supplier part numbers should be used in the purchasing system as a cross-reference list, and in some rare cases, the supplier part number may be used in your own description, but not necessarily used as your own part number. Supplier description, if different from yours, and again, warranty information if required. And continuing on page 6, the supplier repair capability and the lead time, and undoubtedly we would want to check the supplier cost of repair versus our own internal cost, the manufacturer's part number. If the item is purchased from a supply house, we may want to go directly to the OEM, just as we discussed earlier when we talked about an OEM supplying equipment to us and he or she uses OEM spare parts. We would want to purchase directly from that OEM. And the reason is simple: to reduce lead time and reduce purchase order costs. You would have to develop shipping instructions basically for two types of purchase orders. One is for a repair order going to a supplier, and secondly, for items that are going to be returned to the supplier for either credit or replacement. You want the current purchase order lead time and any other information that you feel is required for key major spare parts. So we have just concluded a very comprehensive analysis on pages 5 and 6, and if those are key requirements, all of that data should be embedded in the purchasing item master record. Now, one of the key issues of purchasing and the reason we want full-time purchasing support in the maintenance management program is to address all of the supplier issues, but most importantly, the follow-up of purchase orders once they have been issued to suppliers. So what I have done on pages 7 and 8 is outline the procedures and the responsibilities of purchasing to the maintenance management program. One, identifies the responsibility of purchasing and only their responsibility to follow up on purchase orders. Secondly, the follow-up should be done by due date. So therefore, within the purchasing system, the purchase order file can be resequenced where we have POs by supplier by due date. Item 3, purchase orders that are required for maintenance work orders which are planned should be coordinated by purchasing in the maintenance management program. That is the maintenance work order planning and scheduling system. If the items are for unplanned requirements as identified in item number 4, then that has to be coordinated to the storeroom or the inventory management group. And likewise, item number 5, any rejects that could affect planned maintenance work orders would have to be coordinated between the planner, scheduler, and inventory management. The purchase order rejects and replacements should have the highest priority within the purchasing system, and there must be immediate follow-up between purchasing and the supplier to try and get the most comprehensive ship date from the supplier, and it may require the replanning and scheduling of planned maintenance work orders, and all of those issues are addressed in item number 6. Item 7, it is the purchasing responsibility for open purchase orders, and their responsibility does not end until the purchase order is complete in total. So I think you can see the necessity to have full-time purchasing support, not only to place purchase orders, but likewise to follow up on purchase orders after they have been released to the supply chain. Now, the next 2 pages, 9 and 10, addresses the data that should go on a purchase order when we purchase new equipment. And this is something that I find hardly ever takes place, at least for those companies that I have worked directly for or have met in my various seminars. The first item that is on the purchase order generally is the equipment or asset that we're purchasing. We would indicate what it is by total definition. We could also indicate the quantity required and the total purchase order cost, including any shipping costs that may be incurred from the supplier to you. And that's about the extent of the data that is on the purchase order. As far as I'm concerned, that is not sufficient. We want other line items to be on the purchase order where they are a requirement. And let me walk through some of the data that appears on page 9 and 10 relative to item numbers on the purchase order. Now let me go back. The first item is what you're actually buying from the supplier. It's an item. The second item may be installation information. The third item could be dismantling and moving information. The fourth item could be operational information. The fifth would be the recommended spare parts for the maintenance program of that particular asset or equipment. The sixth would be the recommended PM program. The seventh item on the purchase order would be the recommended minor and major overhauls. And the eighth would be the training of maintenance personnel. The ninth would be the training of machine operators. And this is going to be extremely important for those of you that are going to go to predictive maintenance or to TPM, total productive maintenance. The 10th would be the safety features of that equipment. The 11th would be warranty and service provisions that are supposed to be supplied by the supplier. And guess what? Any additional information that you required. Now, you notice I said item numbers on the purchase order, not notes. When you first issue, let's say, a quote, a request for quotation to the supplier, you should also have those item numbers on the request for quote. When the supplier gives you a price, that automatically ties that supplier into a legal binding contract that all of those items are going to be supplied by the supplier to you. If it's a note and it says we would like to have, that is an indication that the supplier does not have to have legal binding, okay, requirements to supply you with that item. Now, over on page 11, we want to place a notation at the bottom of the purchase order. And the notation merely indicates that payment for the equipment is not going to be made unless all items as listed on the purchase order are received. And if a supplier thinks that you're trying to be fancy with him and you may be in a low cash position, then one of the additional notes that you want to apply on the purchase order is indicate that the monies for the items that you are purchasing are in a bank account. You could indicate the bank where it's located. You could even give the supplier the account number, but he or she cannot withdraw that money until it is released by you. Now, those are some key issues when new assets arrive into your facility. It's going to address all of the maintenance and operational requirements for that particular asset or piece of equipment. Now, there's one additional consideration, and I'm going to go down to 11, which could be a different item number. That could be item 12 on your purchase order, and that is if you are buying offshore, any of the data requirements that you receive, like PM instructions, major minor overhauls, operational instructions must be put in English. Because here again, I've seen companies receive equipment and they don't have the foggiest idea on how to install and start that equipment in production until they've gone through the process of actually changing the language through interpretation. So those are some of the key issues relative to purchase orders when purchasing new equipment. And it would be my recommendation that those two exhibits be reviewed not only within maintenance but with operational personnel, with your financial personnel, and likewise with top management and also facilities engineering. Now, starting off on page number 11, we want to talk about the integration of the storeroom and its responsibility to purchasing and purchasing's responsibility to the storeroom. And the first element we want to look at is what we call receiving validation. In other words, when we receive a shipment from a supplier, is it according to the due date, or is the supplier shipping way ahead of schedule? If the supplier is shipping way ahead of schedule, it may be an indication that supplier is short on cash and is trying to get through his accounts receivable some additional monies. You have an option. If I were you, rather than return the material, I would receive it, I would put it in stores, but I would also tell a supplier that we're going to follow our normal payment terms and that that invoice will be paid at an appropriate date, and you could even indicate the date. If you have overshipments, what are you going to do with the overages? Especially if it's a planned requirement, and those planned requirements are far and few in between, meaning the elapsed time from one plan to another could be, let's say, semi-annually, if not longer. Here again, you should develop the policies and the procedures for these types of receiving validation. Partial shipments, you may need 2 items and you only receive 1. There isn't anything you could do with the 1. You need 2 for a planned order. What is your procedure relative to getting that second item? Non-conform packaging could lead to potential damage of an item. A non-conform carrier means that you could be paying more for freight in as opposed to utilizing the proper carrier. And invalid receipts means that the supplier actually had put 2, let's say, packing slips into the wrong containers, and they crossed the shipping labels, so that there were actually 2 errors made by the suppliers, an error to you and an error to, let's say, another one of his customers or her customers. Now, invalid receipts is a key consideration, especially when you have planned maintenance work orders. You want to get on the phone immediately and determine where that other shipment went so that that shipment can come directly to you and be processed through the maintenance work order planning and scheduling system. Now, continuing on with receiving, we have receiving inspection requirements. Like I said earlier in this program, the storeroom is becoming more and more self-contained. We receive into the storeroom, and also we're providing receiving inspection. Receiving inspection is a function that should be determined by, let's say, maintenance management, your quality assurance or quality control department outside of maintenance, facilities engineering, and anyone else that could lend support to what are the quality requirements, what are those items that we should address in receiving inspection, not for all items, but for those that are candidates for receiving inspection. One of the considerations is, where is it going to be inspected and tested? This could be done by a third party that I alluded to some time ago. And here we would have to add the lead time for that third party inspection and testing to the aggregate lead time of that item. The level of inspection pertains to the lot size we are inspected, and over on the production side, those lot sizes are generally tied in with an AQL level, assured quality level. And in this case, I would encourage you to have the inspection department and operations try and support the question of the level of inspection. Sample size, you may have, as an example, a pre-production purchase order for an item. It could be brand new, it could be a new supplier. You're just trying out how many items do you need from that supplier, so you can go through a receiving validation of that item from a quality assurance or quality control standpoint. Sample testing and analysis is similar to the first item, but that means it's going to be done internally. The types of gauges and equipment that would be required to support receiving inspection may be ring gauges, snap gauges, OD and ID type indicators, and thread gauges, rulers, and potentiometers, and any other application that would be required to support what you are going to inspect and how you're going to inspect it. We have to consider the lead time for the inspection process, and again, we identified that when we talked about the aggregate lead time of a purchased item. And then there is consideration for supplier documentation. Where should that supplier documentation be housed? I may want to put that documentation into aperture cards. They may want to be photoed and put directly into a CMMS database system for supplier data, or maybe the physical documents may want to be filed in the maintenance or facilities engineering file by supplier, and then part number within the supply base itself. The next exhibit pertains to the receiving disposition. Now you may say, that's kind of funny, receiving disposition. Well, it's not funny. We hope all items are accepted, but you and I know from experience that maybe some items are going to be rejected, and maybe there isn't anything you could do with the item except return it to the supplier for rework. Now, the purchase order isn't complete, and what are we going to do about getting a replacement shipment? That is a purchasing department responsibility. But don't forget, this receiving is done in the storeroom. Again, the integration of purchasing and stores. There may be an opportunity where you could rework some items to be able to satisfy a planned maintenance work order. Or maybe you could sort out some items out of a larger lot size to get you by to support a planned maintenance work order. In either case, rework or sorting, you should first indicate to the supplier what the rework or sorting cost is going to be, get the approval that the supplier will approve that cost, so that you don't have any major problems with the supplier at a later date. And scrap indicates that the material cannot be used, and it doesn't make sense to have the supplier pay for a transportation of scrap back to his or her shop. Now, there may be some scrap value associated with scrap, and the way we generally recommend our clients handle that is whatever the scrap value is, either through a scrap dealer or through some salvaging operation, you may want to take 10 to 15% off of that scrap value for your process and handling cost, and then give the supplier the credit for the balance through that scrapping process. Now, the next item on page 14 we will be addressing are those shelf life codes.